picking up where we left off yesterday, you're asked to find the common denominators on those last four problems. Okay, so let's start with number 8. Start with number 8 here, and taking a look at 2x and 5x, what do they both have in common? The x. And what does this one have that this one doesn't? A 2. And what does this one have that this one doesn't? A 5. So 5 times 2 times x. So my common denominator is 10x. Okay? Now that's the common denominator. That's obviously not our answer there, but that was the common denominator. Now I have been asked by some students, why can't I just multiply this by this? Okay? And that does give you 10x squared, which is not a least common denominator, which means at the end you're not completely simplified. If you reference the previous page, some of the core concepts there that are covered on page 207, notice if the denominator is the same, you just keep the denominator, add the numerators. Same thing with subtraction. But when you get down here with unlike, it shows that C and D you could just multiply together. Now, that being said, you want to find the least common denominator. Okay, so that's a little misleading in terms of finding the least common denominator. All right? So, if the common denominator is 10x, I make that 10x, and I make this 10x, what am I multiplying the 2x by to get 10x? 5. So 3 times 5, 15. And what do I multiply 5x by to get 10x? 2. So 11 times 2, 22. So I get 15 plus 22 all over 10x, or 37 over 10x. Okay, that is the actual solution. X cannot equal 0. All right. 2x times 5 is 10x, so 3 times 5 is 15. You got to multiply the top and bottom by the same amount. Okay, number 9. Let's go ahead and take a look at that one. A little different. Note that you have two terms here. You have an x minus 2 and you have an x plus 8. So you can't just say that they have x in common because you're adding and subtracting. Or you're adding the one and subtracting from the other. So in this case, the common denominator would be this and that put together. So the common denominator would be x minus 2 times x plus 8. Now I will tell you that sometimes when I'm doing these problems, it's a lot easier to see my work or to keep track of my work, to show it in a nice orderly fashion. So I like to stack my fractions. So I would say 15 over x minus 2. Forgot the minus. Plus 3 over x plus 8. And so that there's no confusion, let me erase that. Okay. And I know that my common denominator, so what I'm going to do is kind of skip some space there. I know the common denominator is x minus 2 and x plus 8. Okay, I multiply this one by, what does this have? Or not have that I need, or what do I need from here? The x minus 2. And since I multiply the bottom by it, I have to multiply the top by it as well. Okay, this is the number 1, right? So when you multiply a fraction by 1 or anything by 1, you get the same value. So you're multiplying by 1 just in a different form. Okay, so x plus 8 times x minus 2 is that. 3 times x minus 2 is 3x minus 6. I just distributed as I went over. Okay, and what did this one need to get there? X plus 8. And so it's x plus 8 over x plus 8. That's that special number 1. Okay, and 15x plus, I believe, 120. Okay. And then we just add down. We have a common denominator, x plus 8, x minus 2, and 15x and 3x, and 120 and negative 6.
Would it be plus?
Yes, it would be plus. Thank you. Good question. Do you keep them in parentheses or do you multiply it out? Well, right now I'm keeping them in parentheses because the last thing I want to do is factor this and make sure I can't cancel anything or reduce that. And so what comes out of 18x and 114 is 6. Okay, so I could take a 6 out, and that would give me 3x plus 6 into, let's see, 19. Okay. And I can't cancel anything, so I could have left it as 18x plus 114, or I could keep it as, I would accept either multiplied out or in factored form. Either way is fine. So if you left it in this format, so it's 6 times 3x plus 19 all over x plus 8 times x minus 2, I would be fine with that answer. I would also be fine if you multiplied it out. We know that x cannot equal negative 8 and 2. Any questions on that? Now, you do not have to use this format. I stack them like that and usually keep order like that just because that's the way I learned it. It's a nice organized fashion. It suits my type A personality probably really well. But I will also do these other problems in the ways that I see other students complete them. Okay, and if you decide to do it the other way, that's fine, but you better stay organized and make sure I can follow your work and you can look back and follow your work. Okay, so it'll kind of be up to you. Number 10. This is already factored. This one is not factored. If I factor this, what do we get? Okay, thank you. 2x plus 1 and x minus 3. And so the common denominator, excuse me, what do you got? 2x plus 1 they have in common. What does this one need that that one has? Has the x minus 3. So I'm going to go ahead and put x minus 3. If I wouldn't have used pen to circle the 10, that would be better, but that's okay. This one is already set. So my common denominator is x minus 3 times 2x plus 1. So since I multiplied the bottom here by x minus 3, I'd also have to multiply the top by x minus 3. Now this is the way I see a lot of students do the problems. They just do that. Okay, and then they go, well, that equals, they either put it over here and try to squeeze it in or put it down here, and they say that equals 3x times x is 3x squared and negative 9x. All plus 10, right? And that's all over . So from there, are there any questions there? That looks pretty organized, right? It actually looks a lot faster than what I did. Okay? And I'm fine with it as long as you stay organized. A lot of times they get a lot messier, but you've got to look and see if you can factor this, because if you can factor it and then cancel something, you got to do that. So can I factor? Trying to make 30 out of things that will add to 9. 130, no. 215, no. 310, no. 4 doesn't go in. 5, 6, none of those. Okay, so we are done. X cannot equal 3 and negative 1/2. Good. It's whatever would make that 0. Subtract 1 divided by 2, negative 1/2.
use the 10 over 2x squared minus 5x, would you simplify it?
No, you just multiply by 1 over 1. Okay, number 11. A little more complex. There are 3 parts. First thing I do on this type of problem, anytime I see a subtraction sign, I'm going to make it addition and move the subtraction up to the numerator. I promise you that will make your life a lot easier. Make it addition, move the subtraction sign up to the numerator. Okay? All right, so factored. I mean, really, there's nothing to do with it. This is not factored. Tell your neighbor what it becomes, though. Okay, I heard that. That's pretty convenient. All right, because now it allows you to look at this and say, oh, well, my common denominator is? Good. X minus 7 and x plus 1. So that means this entire bottom piece becomes, if you want to think of it, this is the other way I see students doing it. So I'm trying to hit on the different processes that I see students go through, and then you can choose which one works for you. Okay? This entire bottom becomes x minus 7 and x plus 1. That is my denominator. Correct? What did I multiply this piece by? X plus 1. So that top is now x times x plus 1 right there. So if we're kind of thinking that that's our original top. This, what do I need to multiply by here? X minus 7. So it's negative 2 times x minus 7. And what do I need to multiply this by? Yeah, nothing, right? Or just 1, which doesn't change it. So, I see this also. Now, that's kind of organized for me. I'm like, okay, I get it. You found your common denominator. You multiplied it here, and now here's my new denominator. Here's my numerator. Now, when I simplify, though, I've got to be going, okay, that's x squared and x. And I'm going to write that here now. That's negative 2x and 14. And that's minus 8x. Okay, and it's all over. Okay, so we get x squared and this part right here along with that part. Negative what? All right. Okay, what do we need to do there? Factor it, yeah. X plus 7, x minus, x. Unbelievable pen.
The pen messed up, man.
I know, I'm trying to. You think you have a good pen and all of a sudden it makes mistakes. It's ridiculous. All right. So what do I do? Good. You end up with x minus 2 over x plus 1. All of that to get that. Now, can I cancel the x's?
No.
Good. Implied parentheses. X cannot equal. And 7. Can't be 7 either. All right. Who has a preference on the way they show their work? I really am curious, and like my preference is, I really do have a default way, but my preferences change depending on the problem, kind of. Just out of curiosity, how many go this route? How many like this route? How many are this route? How many have another route? Okay, how many of you like have a mixed route? You like, sometimes I do it one way. Okay, as long as your route is nice and organized and clean. Okay, if you have a route that has sticker bushes and all kinds of junk that you have to climb over and jump through, that's a poor route, dude. Okay? Well, it's quite an adventurous problem, I agree. Okay? All right, number 12. Number 12. Go ahead and tell your neighbor what you're going to do.
So you shouldn't be happy about that.
Yeah.
You should be mad.
Well, we have a couple things to point out here. First, Tyler has said that it's not supposed to have fractions in it. I agree. You're not supposed to have a compound fraction. Second, I want to point out when I was going through the sticker bushes, I must have cut my paper right there, so I don't know what happened. Okay. And third, I personally like this next problem looking really cool. If anyone's ever going to make a cool math gift of some sort, that is a mathematical wind chime. If you go like three-dimensionally, have that thing like chiming outside your house, that'd be awesome. Don't you? I mean, seriously. That looks cool. Okay. Now you know what to think about when you look at wind chimes, Ellen. You're like, look at all those chimes. And then you can imagine numbers and X's and everything. That's awesome. Imagine imaginary numbers. That'd be great. You can imagine like 20 times, right? Ask Haley.
Great. There's
Imagine.
so many wind chimes outside my window.
Oh, all right. Yes. Imagine. All right, so we're going to keep those two pieces together, and what we're going to do is we're going to look at the numerator separately and then the denominator separately. Okay, so with the numerator, if I'm trying to simplify that, I've got to think of that as 10 over x minus 3 over 1. Which means my common denominator is, what do they both go into? 10. So I get x over 10, so that doesn't change, minus, I have a 10, so I multiply the top by 10, which is 30. Okay? There we've got it. Howdy. So that whole numerator becomes, Dankeschön, x minus 30 over 10. Now for some of you, you may go, that seems like a waste of my time to even go and do that because look, I still have a fraction up there. But you only have one fraction versus two. Okay? It is better. Yes. JK. Jenna Kumasaka. All right. JK. All right. Just in case Jenna was falling asleep. All right, so this is x. That would have to also be x, meaning I multiply by x, so I get 5x over x plus 1 over x, which gives me
5x plus 1.
Now, some would argue that that looks even worse than when we started. I would argue that this division symbol is actually that division symbol. And really, I could write it like this.
Yeah, I did that too early.
And from here, it's all just math you already know. No imagination necessary. You just go x minus 30 over 10 times the reciprocal. Okay? Ends up giving you x times x minus 30 and 10 times 5x plus 1. We couldn't cross cancel, so that means we're not going to be able to reduce. You could either leave it in that format or you could distribute. However, the answer is x, or excuse me, our restrictions are x cannot equal, go ahead and tell your neighbor what x cannot be. Okay. Good. Okay, 0 and negative 1/5.
Yeah, we got it.
All right. Okay, how many got it? Any questions?
Why would you make the negative one? Why would you make it negative 1/5 instead of
It's whatever makes that 0. So you say 5x plus 1 equals 0 and then solve, and that will tell you the restriction. Yeah, good question. Okay, want you to take a look at 13 and give it your best shot. I'm going to be working. Okay, so if you're looking at what I'm doing here, the numerator I just factored, nothing else I could do with it. The denominator, I have to find a common denominator amongst that. So that common denominator would be x plus 4 and x minus 11. And so I'd have to multiply the 2 by x plus 4 and the 1 by x minus 11. Okay, so I end up with 12 over x minus 11, x plus 4. And in the denominator, I end up with 2 times x plus 4 plus 1 times x minus 11, all over x plus 4, x minus 11. So, with that,
Those two are the same.
you end up writing it in this format, where you're saying this division symbol is the same as that division symbol. So write it as and I'm going to distribute that as I go. All right. And then we combine like terms, right? 3x minus 3. So this would become 12 over x minus 11 times x plus 4 times the reciprocal, so we flip it, x plus 4, x minus 11, and 3, and we should factor this, right? 3 times x minus 1. So make sure to factor that. From that point, cancel, 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 cancel. What cancels here?
That was easy. I do that in my sleep. Coach, give me another one.
Okay, if you start doing math in your sleep, people will start wondering. They'll be like, what's up? What's up with that guy? Questions? Good question. So So Hallie's question, why or what is the reason for doing that? Well, if I were to give you this original problem and say, hey, I've got an input value that I need you to put, or that needs to be put into this function, and I need to get the correct output for it, or I need to be able to put in multiple inputs for it. Okay, maybe that function represents it's the number of widgets I need to ship to make a certain, or whatever. Okay, it will be much easier to input into this function than to that function. Okay, so simplifying it's a good. You have to be able to simplify. Mathematically, I personally find it fun, but that's just maybe a messed up thing on my part. I don't know. Okay.
Why would someone write it like that if they can just?
Well, that's because each one of these different pieces could represent another part of another function, another piece. So. Okay, good questions. Let me know if you have